This timeline tracks humanity's expansion into space. It maps a linear progression of accelerating technological milestones, from the first theoretical proofs to the first commercial orbital habitats. We are conducting a rapid year-by-year audit covering the 19th through 21st centuries. Long before the first physical rocket left the atmosphere, space exploration existed strictly as an exercise in telescopic observation and theoretical mathematics. The chronology begins with observation. In 1801, Giuseppe Piazzi discovered the asteroid Ceres. By 1840, John William Draper captured the first clear telescopic photograph of the Moon. William Moore published The Mathematical Foundation of Rocket Motion in 1813, and William Leach proposed rocket-based spaceflight in 1861. Konstantin Tsiolkovsky expanded these concepts, proposing a space elevator in 1895 and proving the theoretical viability of liquid propellant in 1903. Robert Goddard translated theory into practice, launching the first liquid-fueled rocket in 1926. In 1956, the three-stage Jupiter C rocket became the first to cross the thermopause, achieving Mach 18. By 1956, the foundational physics of spaceflight were proven. The barrier was no longer theoretical, which set the stage for the intense competition of the Cold War. Geopolitical competition catalyzed a rapid acceleration of physical launches. In 1957, the Soviet Union launched Sputnik 1, the first artificial satellite, followed by Sputnik 2, which put the first mammal into orbit. Between 1958 and 1962, the U.S. and Soviet Union exchanged high-speed milestones, including the discovery of the Van Allen belts by Explorer 1, the first lunar impacts, and Yuri Gagarin becoming the first human in space aboard Vostok 1. Alexei Leonov completed the first spacewalk in 1965 during the Voskhod 2 mission. By 1968, the crew of Apollo 8 became the first humans to enter the gravitational influence of another celestial body. The moon race culminated with the Apollo 11 landing in 1969 and concluded with Apollo 17 in 1972. This period also recorded the first space station, Salyut 1, and the first soft landing on Mars with Mars 3. This 15-year window holds the highest density of human spaceflight firsts in history. Every milestone during this phase was fueled by the political and military priorities of the space race. In the late 1970s, the focus expanded to outer solar system reconnaissance. Voyager 1 and Pioneer 11 executed the first successful flybys of Jupiter and Saturn, returning the first data from the giant planets. Missions shifted toward reusable low Earth orbit infrastructure. The 1980s and 90s were marked by the first Space Shuttle flight, the long-term habitation of the Mir station, and the deployment of the Hubble Space Telescope. The 1998 launch of the International Space Station led to an uninterrupted human presence in space starting in 2000. Simultaneously, robotic precision improved, delivering the Mars Pathfinder rover in 1997 and the Curiosity rover in 2012. This phase replaced brief, isolated exploration missions with sustained orbital habitation. It established the logistics and infrastructure required to eventually return humans to deep space. In 2015, the first propulsive landing of an orbital rocket booster disrupted the cost structure of space access. This reusability began a transition toward a hybrid model of space exploration. Between 2021 and 2023, national agencies achieved several major firsts, including powered flight on Mars with Ingenuity, asteroid deflection with DART, and the first landing at the lunar South Pole by Chandrayaan-3. The current roadmap through 2030 integrates commercial missions like Starship and Fram-2, with the government-led Artemis 2 return to deep space. It also marks the planned transition of the ISS to private commercial destinations. This integration of commercial launch capacity has transformed the project of exploration. Private logistics now support the critical path of both national science programs and commercial orbital industry. This visualization shows the exponential reduction in the time between milestones. The sparse discoveries of the 19th century have been replaced by the high-density clustering of events seen since the middle of the 20th century. The 2030 milestone map confirms that space exploration is no longer limited to isolated experiments. It has transitioned into a permanent infrastructure, sustained by a combination of public science and private commerce.